Right, good afternoon guys. Just a short video on how to and why to take accurate measurements, linking in with something called uncertainty. So depending where you are on the course, you've either done quite a lot or you're just right at the beginning. So I am not talking about precision, okay? What we use to measure different distances in the 4 items that I've got here, okay? Ruler, meter rule, vernier calipers, it's the vernier bit that makes it precise, and micrometer, which is very precise, so 100th of a millimeter, doesn't mean it's about being accurate. So this is about method more than it is the instrument itself. Okay, so we choose the right instrument for what we're going to measure in the first place. I wouldn't use this to try to measure the diameter of this, for example. So I also wouldn't use even the millimeter scale on here, because again it's just not going to be accurate. To start with, your scale's not next to your actual device anyway, so you're going to have to be quite hard to get to measurement with it. So I would take this for example. So I'm going to use my vernier calipers, and again a little reminder for those who are a bit stuck with this, you're putting that across obviously the widest bit if we're trying to find diameter, and our number here, our first element on the scale, is where we take our 0 reading. So what do I mean? If I ram it back, when the jaws are closed, when this gap is closed, then our 0 level here on our vernier scale lines up with the 0 on the main scale that runs down the middle. Ignore the top, that's in inches. So I'll open it up, okay, a little screw through, and we put it on the widest bit. And so what I've got here, if you can see that, let's try and get the angle a little bit better for you. What we've got is around about 7.5. It's not quite 7.5, perhaps you can see it's a little bit less. So I'm looking for whichever line on the edge here lines up with any of those. So I've got 7.4 and a bit more, and I think from my scale, let's see, you can probably see a bit better there, the 8th one lines up. So this 8th one here lines up with one of the lines on there, so it doesn't matter what the numbers are in the middle, you've just got there. So 7.48. okay, so that's our reading there. Is that an accurate reading? It's definitely precise. Let's just write it down to show what I mean. So 7.48 centimeters. But is it accurate? Well, we don't know unless we double check it. So what I would do is I would take the diameter again and I would read it off. I'd actually leave it on, which is easier to do. So again, I don't know how well you can see it from the film, but again it's just under 7.5, so 7.47. Slightly different. It looks nice and circular, but they're never going to be perfectly circular. And I will take that again and do it up again, and again it is just under 7.4, as you'd not be surprised. And this one is again 8. So 7.48, 7.47, 7.48 are our values. What makes them accurate is I can then actually get me a better value. Okay, so if I average them, what I'll actually get is almost 7.48. So it's going to be 7.477 or 66666 if you prefer. Now, calculated value can only be as good as the original value, so I actually have to round up. So my value for my average is 7.48, which is 3 significant figures, because these are 3 significant figures. Okay, don't worry about decimal places, but how many digits I've used, because it's a calculated value. So 3SF, because these are 3SF. The precision is how many decimal places I've got, but that's my precision, not my accuracy. So the method here will get me a more accurate value. Now it may not seem almost worth doing, but I have double triple checked that thing, and I would always be looking for 3. If we took a completely different system, so if we went for the wire, most people found this easier when they were doing the Young's modulus kind of experiment. If you take your wire, again, I don't know if you can see how well this works, but some people kind of really crank these up. So again, just using the thumb screw. Don't go any tighter than that. So reiterate that because people have been crushing it. And what we've got there is, you can see the 0 line, you can't see the 0.5 millimeter, so it's almost 0.5 millimeter. It is taking that line across 48. So 0.48 millimeters. If I do it further down, then what I've got there is something completely different. I've got my 0.5 millimeter mark, and I've got something that's very different. So I've got 0.5 plus 0.41, let's say, in which case that would be 0.91. So we're going from 0.48 to 0.91. And it's things like that when you're taking those readings, and again I would do it a third time, take that reading, and again I've gone back to 0.4, can't see the 0.5 millimeter, it's almost there, but 0.49. So straight away you can see there's an issue. Does it make it any less valid? It probably hints on this one that there's something wrong with the wire, and if you look back to where I've just taken it, there's a kink in the wire there. So I've almost doubled the diameter because of it. Not really, it's a kink, so I can't really trust this wire anyway. So I won't spot that if I don't double treble check things. Okay, I would at this stage with the practical get a new wire. Okay, I wouldn't do that because the kinks means it's not going to be an accurate way of stretching it anyway. But how do I know if I don't repeat my readings? Okay, so accuracy depends on repeating. And I should say if I was to swap it, I'd get a new set of readings, but even so, that would be an anomaly. For example, in a different case, that one's an odd one out, so I would ignore that while doing my average. Okay. However, repeating things, repeating times in particular, are really important because they tend to be quite variable. They quite change a lot. All right. So, uncertainty, accuracy, and just a little reminder on how to read my calipers and my micrometer. Okay. Accuracy. Every reading you take needs double checking. Finding the average will make it more accurate.